India, but across the globe. He works very closely with multiple clients across the globe, and he has been a known figure. And we are so glad that Pradipta has been helping us in designing as well as delivering some of our corporate training programs in the space. And today's topic is very, very interesting. This is more because of the kind of demand that we get from our participants that we thought we will keep it this session for a public webinar. And this is on model deployment. Today, the data scientists are not just asked on building models. They have been asked starting from maybe the data engineering part of it, building models, and also deployment. And every client needs different ways of deployment and productionize the whole machine learning models that you typically build in your local systems. And the world out there has so many choices. We have 15 plus choices of actually deploying real-time deep learning models, starting from maybe a small Excel sheet scoring to a completely live application which runs on edge computing to multiple ways. And we thought we will create a series of webinar on this topic, which is on deployment, because this is one of the key area that there are hardly any skills as well as dedicated programs around deployment alone. And today being cloud is one of the center point of deployment platforms. There are again multiple products and different pipelines that the companies are creating for deployment, which making most of us easier to get into this deployment. So it is one is about building the models and helping the companies get to where they want to go using the data. But also it is great to see that whether these models are building so that you can create a feedback loop to the business to take actions on a continuous level. So I know that we have taken a little small stall and started little late due to some technical delay, but we are hoping that this series, this is going to be first in the series. We will come up again with more on this. We are also, we have a dedicated course around this, and those who are interested, please do look at it. And I also want to briefly explain about what we do here at Reva University. We have this dedicated team for corporate training space where we train working professionals and corporates on emerging technologies. And AI being one of our center focal point, we have postgraduate MTech, MSc programs in artificial intelligence as well as business analytics. And again, Pradipta has been an integral part of design and delivery. And also he helps us in placing as well as helping building careers of our participants. So we are so glad, Pradipta, that you are with us, helping us exactly knowing how in industry, in the real sense, how deployment happens and how difficult or how challenging or how easy it is. So I would request Pradipta to take over, and I will stop sharing my screen so Pradipta can take over from here. All the best, and we look forward to great participation from all those who have joined. Please keep your queries up and running. We will be answering those queries at the end of this session. Okay, so over to you, Pradipta.
Hello everyone, good evening. Can you hear me right?
Yes.
Perfect. I will be sharing my screen.
Yes.
Can you see my screen, right?
Yes, we can. We can see you, and the presentation is coming up.
Well, so the machine learning and deep learning model deployment. So why model deployment is particularly a challenge in the industry is that there are different platforms, tools, and different kinds of algorithms which are existing today. Now, if you look at the machine learning pipelines today, so how it starts, so what is the life cycle of ML models or DL models and how it is being utilized? Consumption is most important aspect of building or developing the ML models and DL models. So just for the sake of developing the models, we are not doing the ML and DL models. It is for consumption. Where exactly we are going to use it, right? So that's why it starts with understanding the whole life cycle of ML or DL models. So as most of you already know or aware about how the model is being trained, It starts with a business problem. You identify a couple of data sources that can be used potentially to build ML models or DL models. So of course, we'll go through data collection layers. You will have to clean up the data, perform certain validations, and you have to do like feature engineering, and then you will get into the model generation. The first initial baseline model generation, it is the beginning of training ML models. Then you will go for hyperparameter optimization, which means there are a couple of models which requires fine tuning. What kind of hyperparameters? Hyperparameters are nothing but the tuning parameters to get the best out of an ML model. That's why the hyperparameter, once it is optimized, you will validate the model whether it is good or bad. Now, once you validate the model, then you will go for storing the model or versioning the model. Why model versioning is important is that as you get more and more data every month, every day, or probably every week with different kinds of a frequency, as you get more and more amounts of data, then your models might change. Your prediction accuracy or the model accuracy may change. So that's why it is important to store different versions of the models. Now, once you identify out of all the versions, so there is a model registry. Now, model registry, you can maybe if you are in the cloud platform, you can decide model registry. If it is not, if you are in a offline world, maybe a project need or maybe a standalone analysis you are doing, you are not doing any kind of application integration, then you have to compare different versions of the models and the best model you have to choose for deployment. Then you will go for model deployment. The model deployment can be done using like 13 different strategies. So you have to know and understand. It's not about the technical nuances like, okay, I can do it using Java, I can do it using Scala, or I can do it using Python or Django, any other tool. It's not that technical. Technicality is a challenge. The challenge is to understand the nuances of it, which means the model size, the hyperparameter size, the prediction inferencing time taken to generate one inference, time taken, how soon the inference is required by the application, and who is going to consume it, and what is the frequency of generating those inferences, those insights. All those factors also we need to understand. At the same time, also we need to understand where the model is being utilized. Is it an application? Is it on device? Is it on offline world? So where it is being consumed or where it is being utilized. Okay. So then once you identify the way how we want to deploy it, then model serving comes into picture. Serving is mostly like the typical IT world, we call it like serving a particular REST API, right? So as you serve the model, serving means you are serving the inferences. You are generating the inferences and you are showing the end result to the client or to the application, to the end user. So once the model serving starts, then you have to keep monitoring the results, whether the results are good, bad, or it requires further fine tuning, any kind of validation is required. So you have to keep monitoring the model results. Then next comes the model proving or debugging. So if the predictions are going offline, then it is important to understand that why the model is drifting away from the expected accuracy level or expected inference generation level. Probably you would be analyzing the model maintenance, and once the models are outdated, suppose you have the latest version of the model which is excellent and it is absolutely working fine, probably you don't need the model to be the older models to be in production, so you can do a model archiving. So with given those scenarios, the whole life cycle of ML model, how you start with the model and how you end or archive the models, right? So there are different kinds of needs. How the end user will consume the model results. Suppose it's a fraud detection problem. So it's an online thing, which means you get a data point, you identify whether it is a fraudulent transaction or non-fraudulent transaction. And that's why inference is required online. And you have to do it quicker. That's why it is very, very important. So there are different ways of model deployment. You can deploy using PMML language, which is called predictive model markup language, which means you build or develop a model, you transfer or you can convert the entire modeling script as a PMML language, predictive model markup language, which is a XML based language, which you can integrate with any other platforms. Which means if you are creating a PMML model out of SAS or R software, you can still consume that, import that model in Python, and you can still generate inferences or predictions. Okay. Similarly, the PMML, since it's XML language, you can integrate with other front-end applications like Java-based applications, and you can receive the data from HTTP requests, generate the predictions, and serve the predictions as well. So this PMML is a very traditional technology, I can say, and it's been there around close to 10 years, and which is also a very popular way of deploying the models. You develop ML model and you transfer this as a PMML script and let the user integrate it to the end application and generate the inferences. But the challenge with PMML is that all kinds of models are not supported. There are quite a good list of models they support right now, but there are some complex models, like if you are going for any kind of deep learning models or extremely deep learning models, or especially the neural network models, it's a bit difficult because your PMML script itself will become heavier. Right. So if the model or the XML language itself, it is quite heavy or quite large number of pages or more, it's very difficult to deploy it. So that's a challenge with PMML. Now coming back to the other two methods, we have Python pickle files or maybe a job lib. So you can store your ML model in a job lib format, or you can store your ML model in a pickle format. And the pickle and job lib both are serialized objects. So you convert the ML model into a serialized object. You transfer that object as a package from one system to another system. It could be from one team to another team. It could be one place to the client place, etc. So you can transfer the ML model as a package. That's a serialized object. And you read that serialized object, generate the inferences. That is what you can develop. Both the job lib and pickle both are equally good. However, when you compare both the approaches, like job lib and pickle, job lib is a little better. Why it is better? Because if you are going for large scale modeling, for example, if you are working on XGBoost, extreme gradient boosting model, which requires a large set of arrays that need to be serialized and deserialized, etc. Job lib is better or performance wise. However, pickle is not, or pickle may not be the best option because it cannot handle huge volumes of or large volumes of or large size of arrays. It takes time because serialization and deserialization process takes time. However, if you compare both the approaches, job lib and pickle, more weightage I can give to job lib in comparison to pickle. The other method is a checkpoint. So checkpoint is mostly applicable for deep learning based models, and this like Keras based models, TensorFlow based models, or PyTorch based models. You can convert it as a checkpoint. So the objective of a checkpoint is that you can distribute the training process. Like it helps us in collaborating the results or training processes across different team members, which means I can train, let's take, I'm running 100 epoch. 100 epoch means each epoch is one iteration. If I'm running 100 epochs, 10 epoch I can ask my team to run, and 10 epochs I can ask the second team to run. So like that. And the checkpoint is a way of it's an object, and again you can pause and load it and start training from there itself. That's why the model storage of the deep learning models can be done using checkpoint as well. So if we look at the entire deployment cycle, these are 4 or 5 different ways, or I can say the mediums of transferring the models, ML or DL models, so that we can use it in the inference generation process. Now, having said that, if we look at the other tools, how we are going to transfer this. So in the previous slide, we looked at PMML, pickle, job lib, and checkpoint. These are the 4 different ways. How the end user will consume the model inferences, or what are the instruments or tools to generate this. So overall, we can divide it into 2 different segments: projects and products. If you have a project, so which means it's an offline analysis. So You are running an ML model or DN model to generate certain predictions, and you want to show that result to the end client or end user, and you want to say that this is how my model is performing and this is the analysis. You could prepare a presentation or slides, couple of slides out of it to showcase to the client, which is fine. However, for a product, it is quite different. For a product, we have to integrate the ML model to the applications. We have to integrate the ML model to the end users or customers' applications as well. In that case, product pipeline, if we just look at project pipeline, that is fine. So we can do PMML, we can do Pickle, we can do Job Leap, etc. However, if you look at the product pipeline, there are two kinds of need. The first need is real-time predictions, which means as and when the request or the inference request comes in, we have to honor that request, like fraud predictions, like any kind of anomaly detections, right? And also, it can be any kind of prediction which is required on demand predictions. If we want to generate on demand predictions or real time predictions, we should be using the applications like RESTful APIs. So here, REST based APIs can be used to serve the predictions, to serve the inferences. On the other hand, when a batch prediction is required, so for example, in a supply chain world, you want to generate the prediction, or you want to generate, let's say you are working on a demand planning project, which means all the SKUs you are handling, let's take 1,000 SKUs you are handling. For all 1,000 SKUs, you want to generate the forecasting for next couple of days, let's take 30 days. So that's a batch prediction. You pick up the SKU and you can generate the demands, demand planning or demand forecasting for next 30 days, and you go to the next SKU. So which means a batch prediction. For batch predictions, again, there are three different kinds of tools. You have MLflow, you have Airflow from Apache. Apache Airflow was initially designed by Airbnb, and that's why the name is similar, kind of like Airflow. And there is a third tool which is called Perfect. Perfect is it's a tool which manages the workflows. So the workflow management tool Perfect is typically used to schedule the predictions, batch predictions, to log the batch predictions. If the inference generation takes time also, accordingly the rescheduling or canceling, all those things you can manage it using the Perfect as a tool. Similarly, Apache Airflow is also very useful in terms of doing job scheduling. All the batch predictions can be run as different or multiple jobs, and those jobs can be scheduled. However, the ML flow can be used for both purposes. ML flow can be used for real-time predictions. ML flow can be used for batch predictions as well. However, mostly the ML flow is used for batch predictions. Having said that, there are the next thing is about why do we need, like what kind of different kinds of needs that we have. So at a high level, the needs are on-demand prediction or real-time prediction and batch prediction. Batch prediction, as we know already, we get the data in bulk and we want to generate the inferences in bulk. That's why the batch prediction is there. And the model which we'll be using, it doesn't matter whether it is taking more time or it is taking less time, it's not a problem. However, when you're going for on-demand prediction or on real-time prediction, you can't use heavy models which takes more time to generate inferences. You have to use lighter models. So as an example, if I'm going to use, let's take a deep learning model for spam prediction, spam or not spam, email prediction. The inference generation, which means incoming email, should be classified as spam or not spam, right? It may take more time. However, if I'm using a lightweight model, for example, a naive-based model, for example, a very simple rule-based ML model, then it's quite fast. The inference generation is quite fast. So, batch prediction, not a problem. On-demand prediction, we have to classify the algorithms based on high complex algorithms, which takes more time to generate inferences, medium, and very fast algorithms, which takes less time to generate the inferences. So next slide, what we're talking about is how the real-time prediction or one instance prediction happens and how the batch prediction happens. Instance prediction. So this is a very simple input-output format, which is you have a wine quality. It's one of my favorite dataset, wine quality dataset, which I use in my classrooms also. The wine quality has different features, 11 different features, and you need to predict which class it belongs to. So I just transformed the quality column and classified into three qualities: average quality, good quality, and bad quality. So three different qualities, and based on the initial data set, you'll find continuous variables, which I have classified into three different categories. Now here, in terms of a online prediction, which means one instance prediction, you will be always online prediction. You will be always getting one instance. So one instance means one record or one sample of wine. You will get all those parameters like your fixed acidity, volatile acidity, so on and so forth, and you will pass that to ML model. Your ML model will generate one inference. The inference would tell you the prediction, class, and the probability associated with it. So this is the input and this is the output. And if you get a second request, that would come as a second request from second sample. So you will be getting in sequences. Now here the catch is, if it is application which is being consumed or which is being utilized by multiple users, then concurrency is a problem. So if your inference generation process itself, it takes, let's take 1 microsecond, and there are 100 requests, like from 100 people there, putting the sample to generate the predictions, then you have to think about how do we manage this concurrency here. Because every 1 second, since it is taking 1 millisecond, it's not a problem. But if there is a concurrency, at the same time, 100 users are hitting to generate the inferences, you have to manage it. So there is a need for an orchestration layer there to queue those requests and generate the responses. In a batch prediction, what happens? The same use case, if I just take batch, you just upload, let's take 20 samples, 20 wine samples. On the left-hand side, you can see this is the input. And you hit the ML model, the model will generate the 20 inferences for that particular sample. Now here, that's why there is a difference between batch versus real time. Real time is associated with applications. Batch is mostly it's an offline process because no user would generate inferences for multiple samples. But if there is a case, then again you have to tweak your application to take the input in the form of Excel sheet or CSV file. Somebody can upload and generate those inferences and download those inferences. So that's why there is a difference, slight difference between online, which is one request at a time, and batch, where you upload a batch of data and you generate the inferences. Okay. Now the challenges of this runtime deployment of models. One is when you are building a product, you need to think about the security and authentication layer as well. So first you have to verify that whatever request you are getting, if that is from a genuine user, and that's not from someone like some hackers or someone else. So you have to authenticate whether the genuineness of that particular request. Second important is if I put garbage. So as an example on this, if I just put something as null, instead of 0, I just put null, or I just put some text over here, then there has to be a validation layer. It should not hit your inference engine. Why? Because it may corrupt your model as well. It may corrupt any other layers as well. So data validation layer is very important. So whatever data you have designed, the typecast. So whatever input field you are defining, you have to define the class, the schema you have to declare. Is it float? Is it integer? Is it string? Whatever it is. If you define it, it's quite easy. So you can just validate online and you can generate inferences for that, right? Latency in scoring and prediction is also another challenge. Latency, if it's a big model or a huge model like a XGBoost model which generates or which has higher number of parameters, then latency would be coming in terms of inferencing or scoring. That's a challenge. And also ease of recovery or fault tolerant system is required. The runtime deployment problem would be arising like if there is some kind of garbage or some kind of wrong data or incorrect input is being passed, it could lead to like getting corrupt the model or getting corrupt the any processes as well. Concurrency is important since we are using a fast model. It may generate less. It may generate inference in a less amount of time, like 1 milliseconds or 2 milliseconds. But if multiple users are hitting at the same time, how do we optimize that? And complexity of the model, which I was talking about, simpler models like linear regression to little complex like random forest and all to more complex like XGBoost or something like any kind of complex models like SVM based models, right? So these are challenges. And batch mode deployment is required when we have a batch of data or consistently we are getting at a very frequent interval some amount of data we need to generate inferences. But batch mode is not a problem. You can always debug it and you can always you have time, you can handle it. Online is a challenge. Okay. Next, the model deployment options that we have. First, we have to identify how we are going to deploy it, static way or dynamic way. Static way deployment, it's not a problem. Dynamic way on a server, which we have to think about concurrency and the speed of generating inference. Those two dimensions we have to think about. However, if you are doing the ML deployment on a device, both static or dynamic, both ways has challenges because your model can't be heavy. Your model has to be light. Otherwise, your device can't or deployment on device can be a challenging thing. Okay. So in terms of dynamic deployment, you can deploy the model parameters or equations like a static equation. You can deploy the ML models as a serialized object using either a pickle object or using a job-lib object. You can deploy the model to the browser itself as a curl command. You can pass the parameters and generate the inferences. You can deploy the model through PMML standards as well. And also final option is about as a web service, which is creating a RESTful API. These are the options that we have. The checklist that someone has to follow while model deployment is input-output definition. What is the expected input? What is the expected output? The confidence score that defines the model standard, whether it is good, bad, or the prediction is not good, the confidence score is not good. Performance metric, whether the model is in line with the expected performance level or not. And also the model monitoring limits. So the model accuracy may drift, but the drifting has to happen within a certain band. And if it is going beyond that particular band, then that should be generating an alert mechanism, right? And also at the same time, versioning is also important. Which version of the model you are deploying or which version of the model is generating the inferences, that also we need to know. Defined the version metadata also very important. That gives you an idea about when the model got trained, when it is deployed, and what are the hyperparameters, which type of model it is, how much space it is taking, and how much time it is generating inferences. Okay. The caching need for high computing models is also one of the factor, but caching is it has it's a double-edged sword, which means it has pros and cons as well, right? So, having said that, at a high level, we know that if we want to get into the web service mode of generating inferences, then there are various frameworks. We have Flask API, we have Fast API, we have Pyramid as well, and using other RESTful APIs from cloud providers is also another option. We have plenty of options to deploy the ML models. The DL model has some extra or additional challenges. It has typically a longer training cycle because whenever you get a new data, if you want to retrain your models, all the time it should be running in the backend in a batch mode because as we know, the deep learning models are getting batches of data and generating and gets the model updated. So you keep on running the batch data all the time. And of course, as we know, the more wide network or deep network we select, the number of parameters would be more, and number of hyperparameters, as we know, are also more. The large model object size is also a concern. So if you look at the transfer models, which are like pre-trained models or deep learning models, which are typically used for natural language processing based tasks, and also the model object size is more. And if the model size is bigger, and you get the inferences or you want to generate the inferences, the inference generation time would be more. Similarly, if you get more requests, like multiple concurrent requests you are getting to generate inferences on a large model object size, then of course latency would be there. and it's very difficult to fasten that process. How to fasten that? If you want to remove certain layers from that model object by removing certain parameters, because in deep learning you will have trainable parameters, non-trainable parameters. So you could remove certain non-trainable parameter layers from the deep learning model object, and thereby you can reduce the model object size. But it has certain limitations as well, because sometimes it may lead to like drop in accuracy as well, and you have to take care of those two angles as well. And it's also very difficult to deploy on devices, because if you are like having like a speech to text conversion or some kind of a transfer learning is required on device, it could be problematic because the volume of or the model object size is quite big, right? So these are typically the options. And before getting into the question answer, so here what we can do is first I can show you one way of model deployment as a, but that's not limited to, and we have different options. So fast API is a latest it got released in the year 2018, and since then almost like it's 3.5 years, and it's quite modern and it's quite good as well in terms of testing out. So building the API, the RESTful API, testing the API is important. Now after that, how you want to connect it and where you want to connect it, or how you want to connect to what type of systems, whether you have cloud deployment or you have deployment somewhere else, how to connect it, that's a different task. Okay. So why we discussed about all those strategies is that because you can't change the pipeline, the whole pipeline, and if you have identified something incorrect pipeline and you face the roadblock, you have to change the whole thing, which is very difficult. So strategy is important. Once you adopt the right strategy, and it's just about figuring out what tool to identify, how to integrate, that's not a problem. So you have to spend a couple of hours just to figure out how it can be integrated to what kind of system. If you want to write a custom wrapper or you want to write some Python programs to integrate it, that's not a big deal. You can do that. The strategy is more important. However, there are some advanced tools which are coming up. Like you have tools like if you go to Azure, you have like experiment and pipelines. If you go to AWS, you have auto inferencing, which is you can use endpoints and you can use Sagemaker to deploy. So in future also, the integration would not be a challenge. Development of a model and identification of the need, whether it is real time or batch, and also identification of a particular model, which model it is required, and how to integrate this. Gradually it is getting refined and it's becoming easier for us. So on a local mode, if we want to develop an API and we want to generate inferences, that demo we can show right now. Okay. And if you want to get into like a cloud kind of scenario, which is also pretty easy to deploy, which we can cover maybe in subsequent sessions. Maybe we can dedicate one session completely for Sagemaker pipeline, how to get started by importing the data, developing the models, deploying it and testing it, verifying the results, looking at the monitoring stats, etc. So the entire pipeline we can look at. Okay. So right now I'll be moving to a folder. So how to get started on this model deployment. So this is the you can just create a small folder on your any kind of drive. So it can be C drive, D drive, or anywhere on the location. And this is again using this same wine quality data set that I had shown you in the slide itself. This is the CSV file or the data that I will be using. You need three things. First thing is that you need the pickle object. Again, if you want to serve the model inferencing through web apps or through RESTful APIs, you need to again have the pickle as well, pickle object. Okay, so this is just one angle which we are covering today in the session. Maybe in next subsequent sessions, we can look at other ways of deployments. For example, like using either ML flow or some other tools, we can show that. But today, in this session, I'm just going to show how we can generate or how we can create or test out the end-to-end API using this fast API. Okay, so to get started, you need to place your CSV file or data. So now this can be extended. If you want to connect to a database, you have to put that in the code and you can change it. And if you are getting the data already in a CSV format or a text format, you can place it in a folder. Okay. Now this folder can also change. If you are on a AWS scenario, this folder, entire folder can be in a S3 bucket. If you want to use the Azure platform, the Microsoft Azure platform, then entire folder you can generate as Azure Active Directory, where you can keep all those things. Okay. So a CSV file is required. The pickle file is also required, and an app is also required. So three things would be required. Okay. Now, in comparison to fast versus Flask or fast versus Pyramid or fast versus some other tools, there are so many libraries also available. That comparison we can cover it maybe in subsequent sessions. But today, so these three things are mandatory. You need to have a data, which is CSV. You need to have a model, and you need to have an app. So that app should be running. The app would be connected to the pickle file. The pickle file would be generated using the input data, and you need to have a script that generates the model object. If your model object is being already generated by someone else, it's already created by someone else, then you don't need this model.py. The model.py script that you see here, it basically generates the pickle file and it places in this particular folder. So that's why you need. So the model generation, they start with the model generation. If you go back to the first slide that I showed you, so it's the data. The problem here is how can we classify the wine samples into good quality, average quality, and poor quality. Okay. So this is the CSV file, and here I need to generate data. So what you can do here is you need to have the notepad also. Either you can use Notepad++ or you can use this Sublime text as well. So I'll just open up this model script first in Sublime text. So here what we try to see, I'll just explain it. So first what we're doing here is these are some of the libraries which we are importing. Then we are defining a class which is wine quality, and the data types we are defining. So these are different columns, 11 different columns we are using as present in the wine quality CSV file. And these are different data types. So you can define, these are all clean, which is like all are numeric. So you can just define it as a float. Next step is just create a wine quality model class, which has three different functions. The first function is it will read the CSV file, and it will first try to get whether the model is already existing or not. If not, if it is existing, it will try to load by using the job live.load. It will load the pickle file. And if it is not, then it should train the model. Now, train model function objective is it takes the y, which is quality, and it drops the quality and takes all other features as x. And you can just train. So this model can change. You can just put any model. And also, if you want to extend this to add a grid search to run multiple models and get the best model out of it, that also you can do. So this step can be extended further. Now, for the time being, I'm just using one single model, and you are just using model.fit x and y, and you'll get the trained model object over here. Now, once you get the trained model object, next step is about generating the predictions. This is another function, predict wine quality, and here you'll add all those columns that are available over here. Then this is the input data that you'll be collecting. So the features that you are defining over here and the data types over defining over here, this is to collect information from the user in the front end. Now, once you receive that, that would be coming here as a dictionary. So this dictionary object needs to be passed through to this predict function, and it will generate the prediction. And same data should go to the predict prop A, which is to generate the predicted probability for each class, and max probability. So if you have three classes, it will generate three different probabilities. Each probability value is corresponding to one particular class. So then you can collect the max probability, because based on the max probability only, the predicted class is being labeled. And that's why you can just collect the prediction and the probability associated with it as an output. Now, this is the entire model training process and defining the input type of data that you would like to collect it from the end user. So this is to generate this wine quality pickle file. Now, once it is generated, The next step is going to go to the app.py creation. Now in this step, I'll just open this up as well. So in this step, what we're trying to do, UBCon. So UBCon is the server, and from Fast API import Fast API, and from model script that we run over here, there are three class functions. So we'll be importing two class functions, wine quality model and wine. So these two class functions will import over here. We'll initialize the Fast API object over here, and we'll also call this wine quality model and model object over here. So create the app and model object both. Then you will route the call to the predict. So app2, just I have given a name, app2 post. So it is using a post method, and slash predict is to route the data that we'll be receiving, and predict wine quality. So this is taking the data in the form of a dictionary, and it is passing the data to predict wine quality function to generate the prediction and probabilities. And finally, to run this UBCon server, you can just run ubicon.run app2. This host and port that you define over here, local mode, it is host and port, and in case of a cloud mode, you can define based on the endpoints. You can change it or you can modify it, right? So that's why, so this is how you will design the script. Next step is going to the terminal to call this to run this particular. Now what I'll do here, I'll just close the terminal and create a new terminal, and I will just change the directory. So here I will go to and here which directory I'm in, downloads and model deploy. So just check, I have model.py, app2.py, wine quality CSV, it's there, and the pickle file, it's already there. Now to run this model, so what I'll do here is that ubicon app2, and reload. Just click on this. So next step is it will be giving you the URL and the port ID. So started reloader process, started server process, waiting for the application startup, and application startup is complete. Now once you get this message, copy this URL, right click, open URL, it will take it to the browser. So here you can see, by default it will show you not found, details not found. So what you can do here, just /docs. /docs, if you just create, so it's using the Swagger like UI, and using Swagger UI, it will generate this default page for you. Now this is a post method you have already defined, post/predict, and the model object name is, the model class is predict wine quality. To test out the application, whether the application is working, whether the API that you have created is working or not working, you have to provide the input data in this request board. This is the schema for all the input variables that you have defined, and these are certain example values. Okay. Now in this case, you can see this is the successful message code is 200, successful response code, validation error, if it is there, so it will come as 422. Now here what you can go, click on try it out. When you click and try it out, it will give you an option to provide the input data. Now suppose I will go to my slides over here, and here on the slide we have some data, right? So let's pick up the first one, 8.1, 0.27, etc. So let's take 8.1, 0.27. So I'll just take some random input values. So here 0.3, 2.0, let's take 1.0. This one, let's take 4.0. This is 5.0. This is 0.6, 0.4, and this is 0.2. This is 0.01. So these are my input values, and I'll click on execute. So post execution, you can see the response is being posted as a curl command post request with the dictionary object which contains all the input values that we have provided over here. Now it is already generated the inference for us. The average quality is being predicted as the value, which is the predicted class, which is matching. So this is average quality, and the probability associated with it is 0.52. So which is a successful response. Okay. Now, if I give some kind of junk values over here, so I'll just give here as none value over here, and I'll click on execute. Now, what happens? It throws the error. So the error code is 422, and here you can see the message. The expected values here is none, which is causing the issue, right? So that's how you will understand the value error. So here type, you can see the value error, and that's why you can fix the results as well. So suppose instead of none, I will just put 0 now. Now I'll be able to see the results as well, the predicted probabilities as well. So this is how you can test out, and the URL to be provided, the request URL to be provided would be this one. Now you can use this URL as well on the header, and you can start providing inputs on the browser itself using the curl command as well to generate the inferences. So this is a very small task, and if you want to generate the documentations out of it, so you can also generate it. This is if you want to documentation, and this is how you will generate the predictions using Fast API. And there's a very simple use case. Now you can extend it and put additional things and make it complex as well. So complex as in like handling different data types over here, or showing respective errors, putting the logging mechanism over here to understand where it is actually broke and all, and extending the model types, including different kinds of models, and just looking at the grid search, performing grid search, looking at the accuracy of all the models, selecting the best model. So all those things you can extend. This is a base thing, and you can further extend it, right? So yeah, that's how you can do it in a local mode, and in a server mode you can change the host and port ID, and you should be able to generate inferences. Now this is about offline process, but if you want to generate inferences using online or cloud-based solutions, so it's quite easy as well. So we can cover it maybe in some other sessions. So maybe for AWS we can take one session, for Azure we can take one session, and for Databricks also we can take one session. So there are different kinds of cloud platforms, and each cloud platform has its own nuances, and the tools are also available, and those tools makes it quite different from like one platform to other platform. Okay. So with this, I can take a pause over here, and if you have any questions, I would be happy to take it up.
Thank you, Pradipta, for a quick demo on the deployment, at least with one use case, which is great. We have a series of questions which come. Some are basic, some are very advanced. So maybe we will pick about 4 questions and see where it goes. So we have, starting with our YouTube viewers, one of the question is, how do we scale up a model into a production? How do you scale? How do we scale the model into production during the deployment?
How to scale up the model? See, your inference generation scaling is required. I think that is what you are talking about, right? So scaling up to multiple users. That's what I think.
Scaling up to multiple users would be the intention, but yeah, that's...
Yes. So how to scaling up to multiple users is that then you need to have an orchestration layer. For example, you have layers like Kubernetes on AWS, you can say. So you can allocate dynamically different boxes in the Kubernetes scenario. Your particular model object can be placed in each of the boxes, and you can maybe divide like 10 requests to it should hit one box, and next 10 requests should go to another box, like this, so on and so forth. As you get more and more input requests, then your this Kubernetes scenario would automatically generate those boxes and to honor those requests. So it's massively scalable. So you can keep on expanding the boxes. Now that threshold of whether 10 requests can be honored in one sequence or not, that you can take by looking at like how much time it is taking for one request. So based on that, you can identify what is the maximum number of requests that can be honored by using one particular box in your Kubernetes scenario. And based on that, you can just put it in auto scale mode to add more and more boxes to the cluster as you get more and more input requests. That's how you will scale it. Now, the scale up is with respect to the inference generation process. Now, model, you are not really scaling it up. Model has two processes. Model has training process, inference generation process. Your model training process, if you want to scale it up, yes. If you want to like go for a complete deep learning model, which takes almost like 2 days to run, what to do, then you have to scale up your infra actually to train it, right? So the inference generation process, if you want to scale it up, you can do it in a managed cluster and using Kubernetes scenarios.
Okay, great. As a follow-up question, the question is that are there any preferred cloud deployment provider as a vendor? Is it AWS is better in scaling in terms of cost, or GCP, or Microsoft? It's another question.
Yeah, it's quite difficult to answer this question, but I have a preference for AWS and second preference for Microsoft Azure in terms of inference generation. And Google Cloud, yeah, I mean, maybe I will not be able to comment on that. I'm not sure. But if someone asks me, I can get the answer. First priority should be AWS, second should be Azure.
Okay. Yeah. So that's mostly from the Pradipta's experience. We are not endorsing or know any of these products here. So
yeah,
let's
that's probably based on my experiments. It could be biased also, but that is my personal experience.
Yeah. And from our Teams viewers, we have a few questions. One is that mobile application while I am building for a pre-trained CNN model, what are the points that we should take care of?
Right. So on device, I think the challenge here is I'm sure if it is a CNN model, it's a object detection or kind of model. So you have to go for something like TensorFlow Lite is there. So you can take a TensorFlow Lite, and there is something called TFX based inferencing engine. So if you just do a Google search, you'll get it. So it's called TFX. TFX pipeline is there for any kind of deep learning models trained using TensorFlow, and this is lightweight modeling. And this lightweight model, you can use it for inference generations.
Okay, thank you. So one more question, a series of questions from one of our project, I am assuming. So one is that how do we serve model for video processing applications? And especially if you are using WebRTC, how do we serve the model? Because for different facial recognition or post detection applications, how do we do the live serving?
Right. So when you say video processing, so what is the inferencing you are generating? What is the end result?
End result in this case, assuming is that the anomaly detection, especially on the video detection. So.
Right. So if it is anomaly detection, I think. So how many input frames you can provide in a specified time period to identify or to generate a flag? Now, I would say you can use a pre-trained model over there, and though the need is real time, you have to generate those anomaly detections in real time, right? So you have to go for maybe high-end devices like kind of high-end machines to generate those kind of inferences. Because in real time, what you have to do is you have to collect the frames and do the pre-processing and generate inferences, and that has to happen like quite fast, right? So you have to go for higher end machines for serving those kind of inferencing.
Yeah, I think it's a very large question, cannot be answered, Ravi. Okay, so I think more or less some basic questions have come in. What is UV-Con server to how a pickle to be generated? And another set of questions is that what's the difference between a fast API and a RESTful API? These are some of the regular particular question.
Yeah, I think, see, RESTful API is that it's called representational state transfer. And there are different ways of generating those REST APIs. And there are two common frameworks today, which is older framework is Flask and recent framework is Fast. There is a difference. The web server which is used, so the online prediction is mostly happening using the HTTP protocol or HTTP way of generating online predictions. The HTTP way of generating inferences has to route it through a server, the web server. The web server, there are different kinds of web servers. There are Flask server, there is a Unicorn server, there is WSGI server, ASGI server, and the Unicorn server. So Unicorn server is the most recent and advanced one, and it is quite fast. Now, if you are using a Flask uses its default Flask server, right? So there is a difference. Now, if you are using Unicorn, that's a recent framework, and that you can use along with the Fast API. Now, that's how you can like serve the model inferences. Now, coming back to more pickle object generation, so there is a library or a package in Python which is called the pickle. You can use import pickle to initialize that. Once you train a model, and you can just put the model like pickle.load or pickle.dump. Pickle.dump is to transform this model object. Model is a Python object, or if you're training in a PySpark scenario, it's a PySpark object. And if you're generating the model using the keras or PyTorch, this is going to be a corresponding object. It's just an object. The object would be transformed from respective, like a Python object, to a serialized object. Those serialized object you can transfer from one place to another place or one server to another server. And while generating inferences, you have to load that object and deserialize it. Now that serialization process is transforming from one environment to a serialized object, and you can use it in another environment and deserialize it and upload it. To store it, you can use pickle.dump, and to reuse it, you can use pickle.load. You can use it. Right? Similar way, you can do a job heap as well. These are two different ways of storing the ML models or DL models.
Okay, so we'll take a last question. The writer has written it's a very silly question, but we don't think so. This is a great question. What you have already spoken is all about supervised models, but if the unsupervised model running, and how do you actually do on a live serving on an unsupervised ML model?
Right. See, unsupervised model, as the name suggests, there is no inference generation which is required there. In case of supervised only, you need to generate inferences or predictions. Unsupervised, it's just about classification. So you don't really need to generate the predictions, right? So there is no need for like inferencing or model serving in terms of this unsupervised learning models.
Okay. So it's a very fair question, I think.
Yeah, it's a fair question. Correct.
Okay. So great. I think more we covered the question, and I would request that you just move the slide to the where we would just want to give a small glance of the program that which we run, and with that we'll close.
I'll just share it 1 second. You can see my screen, right?
Yes.
I'll just put it on full screen mode. Yeah, you can see it, right? Okay.
Yes. Yeah. So just wanted to conclude this talk by Pradeepta. So what we do here in this program called MTech in Artificial Intelligence is an end-to-end life cycle of AI/ML projects and products and productionization. So it's starting from your understanding how to get the data, irrespective of the structures or unstructured data, and then building the models, not just on the structured, but also video, images, NLP-based models, and then deploying it in real time is how this program is designed, and mainly designed for working professionals who have at least about 3+ years of experience and who have good understanding on the ML world out there and very passionate to build their career into this. And this is a very research-driven program because we believe in real-time projects coming to our participants. So some of our participants are working on real commercial projects, which includes one of the questions which has come on this video imaging projects, which is a large-scale project, and multiple participants are working on it. So, and multiple such use cases that which we are building it as part of our consulting activities under Deva Academy for Corporate Excellence. And all the mentors who are part of the teaching also is involved in the research, and especially the projects are taken very seriously into this program. The requirements and everything else is available in our website. And if you see the next slide, Pradipta, that the program is divided into trimesters, into about 6 trimesters, where you would dedicate at least about a 1/10 of your time or more than that into projects. Along with, you would work on various modules which are very, very hands-on, industry-driven, practical program is what we have been designing. And every trimester has certain theme, and we focus mainly on the computer vision and NLP based projects, and very, very suitable for people who would want to get a full picture on how AI world works out in real time. And we have seen great transformation in people's perceptions after joining this program. We also have another parallelly have a MBA program in business analytics, which also runs on the same day, where we would look at business problem solving through ML and AI techniques. And again, a very hands-on program with multiple tools and techniques and frameworks. What is available in the industry is what we would showcase and make you skillful. So we request all of you who have joined this session in this evening, along with Pradipta Mishra, that please go through the website and just have a glance on it, and we will be ready to help if you have any questions. And maybe slide is thank you. So we would put that up. And first of all, our heartfelt gratitude for Pradipta for quickly demonstrating, because having a demonstration session during this webinars is quite a tricky task. But you did it so well and simplified this complex process of deployment in the best possible manner. And I'm hoping that this session was liked, and participants are excited to actually experiment on. These videos would be available in the YouTube and our Deva Online website, as well as other social media channels. So please go through and please do experiment, create your own applications running, test, because Wine data set and everything is available online. All these are free, so please make use of it. And we wish everyone a happy learning and a very good night. Thanks so much, Pradipta, and thanks everyone.
Thank you. Thanks everyone. Bye-bye.
Thank you. Thank you. Bye-bye.
Yeah, thank you.